so I've just gotten confirmation that the audio is working. So, yep, sorry about the delay, everyone. We had a unforeseen power failure that set us back. That was also the cause of the stream crash earlier. But we're here, we're streaming, we're live, and we're going to go through some challenges. So, I'll go through a couple of the forensics challenges, and then I might go through one of my favorite crypto challenges that haven't gotten many solves. So, forensics is really the art of finding the needle in the haystack, and in terms of the challenges we have here today, we sort of have, three general categories. We have some of just the warm-ups, which are these over here, the 50-point Welcome to Forensics and renamed ones, and then we've got some file forensics, so things like SOMETA, fossilized images, and leaked hexa, and then we have a little bit of network forensics, which is the cookie in the haystack, and basic auth hacks. Now, it looks like, surprisingly enough, more people have solved the Wireshark network forensics challenges than the file forensics ones, which I didn't expect. But I'll go through a couple of them anyway, especially because there'll be people out there who haven't solved some of these challenges. So, I'm going to start off with some of the... let's go... I'm going to start off with some of the file forensics ones. So, over here, I've downloaded just a couple of the challenges, and if I go to just show you them in the File Explorer, so we got a couple different challenges here. Now, in terms of an approach to file forensics, really, there are a couple of basic things that you should be doing with any sort of unknown file forensics type thing. First of all, you should look through and see what the actual thing is, see if there are any clues in the actual content of it, as it's designed to be viewed by humans. So here we have a PDF with some memes. Okay, maybe there might be a clue in the term meta, but there's no actual flag here. Right. So, once we're done with doing our initial discovery, just looking through, one of the first things we want to do is look at the actual contents of the file, as in, view them in a text editor. Often this won't get you much, but it can sometimes give you a hint as to the nature of the problem. So for example, if I open, say, meta.pdf, then I can see, okay, it's an encoded PDF. Now, that can be a little helpful, but that's still really just a bunch of gibberish. So the nice thing about Linux is that it has lots of tools that help you with this. So instead of going through everything manually, what we do is we use tools. So for example, one of my favorite commands for forensics and challenges in general, and something that often challenge creators forget about, is the very simple command called strings, which will try and extract strings from a binary file or any other file. So I typed in strings, and it put it through a bunch of rules, and it tried to find flags and what have you. So, while this won't work for everything, it can actually get you useful hints and useful bits like video handler, and in the case of one of the challenges here, it'll get you the entire flag. Now, another one of the things that is really useful to look at and often gets overlooked by people is metadata. So, there's a tool called EXIFTool, which, if you run it on any file, it'll give you a whole bunch of data about that file. Now, for example, we have a challenge called meta with a file called meta.pdf, and because this is a beginner CTF, that's a bit of a giveaway. So, as a free one, and I'm pretty sure I sanitized this so you won't get the flag from the stream, you'll have to run EXIFTool yourself. If you run EXIFTool on meta.pdf, you see a whole bunch of information, including, oh, the creator was Monsec, and the producer was sanitized hint hint look here. So, without giving you the flag, have a look at the producer on the actual challenge file. Now, The other file forensics challenge that I want to have a look at is the tomb. So the tomb is an interesting one because, well, initially you have no clue what it is. I'm trying to open it, and it says I can't open it, can't view any meta information. Let's see if it's got any metadata. It's got nothing, it's just the data about it, how big the file is, what it's called. So, ordinarily, you identify what a file is, or a program rather identifies what a file is by two things. It identifies it by the extension, so for example .png, and also identifies it by what are known as magic bytes in the header of some file formats. Now, if both of those are missing, it's very difficult to tell what a file is, but fortunately there are often lots of heuristics we can use, and there are smart people who have figured out those heuristics and created a tool such as file. So what file is a tool that identifies what a set of data might be, or what format it might be in. So if you see, if I run file on hidden.png, it identifies it as an 800 by 600 PNG. So what happens if we run it on the tomb? Well, we can see that it's a zip archive here. So that's interesting. What happens, what if I just rename this to the tomb.zip and I open it up in a file browser, in a zip reader? Well, it says, I can't read this. This isn't the right file type. And that's because of the second part, which is the magic the magic bytes inside the header. So, let's just open the tomb. And if we look here, this is the header here. This is all of the information about it. If we look at the actual file spec for what a zip header should look like, we can see that there's a whole bunch of data here that should be here. So if we compare this diagram here, the local file header, to our hex editor here, we can see that there should be some sort of signature in the first 3 bytes. There is not. We can see that there should be a CRC32 hash over here. There is not. There should be a readout of the compressed size and the uncompressed size here, as well as a couple of other things. So I'm not going to give this one away beyond this, because most of the challenge is figuring out how to repair the header, and a lot of people have already solved this, but this was one of the more interesting file forensics challenges. Onto network forensics now. So the two network forensics challenges here are mostly just an excuse to get familiar with Wireshark. So they're both fairly trivially easy. The real challenge is really just using this tool called Wireshark, which opens .pcap and .pcap-ng files. So Wireshark, for those who don't know, is a packet capture and analysis tool. So with Wireshark, you can capture all of the packets that are getting sent from your computer or across the network. So you can see here we've got a bunch of TCP packets, we've got some HTTP going on, etc., etc. And you can view it after the fact and actually look at the raw data. So we can see here, TCP, blah, 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 blah. Now, there's a whole bunch of noise here, and really what we're interested in is trying to find the data from the noise, so the needle in the haystack. In this case, this challenge is, this challenge is basic auth hacks. So I think I captured some data of a hacker trying to log into this site. I think they even tried a flag. So immediately I go, well, if you're trying to log into a site, you're probably talking about HTTP. So what we can do is we can write a filter and filter out everything except for HTTP. And now what we see is the attacker made a GET request at this time, then the server sent back OK, then the attacker sent a POST request to submit. So that's an interesting one. Post requests mean that the client is sending data, and if we actually look down here, we can look at the HTTP. So what do we see here? We see blah blah blah, we see username equals admin, password equals password, submit equals submit. Okay, that's interesting, that might be one of the attempts. Oh, so looking at the next submission attempt, we see admin help submit. And so in doing that, we can see that we're actually looking at the data here. I'm not going to show the flag on stream, but the flag is located in one of these requests. For those of you who haven't done it, or just, or just, like, maybe someone on your team's done it, but you don't really know how it works. The solution for the cookie in the haystack is much the same, except you're looking in a different place. Finally, I'd like to go through Dr. Octopus, because there are only 5 souls, and it's one of my favorite challenges, and I think that's tragic. So, Dr. Octopus is a bit of a crypto/misc all combined in one, and it gives you the source code, because this is really one about trying to exploit the principles of a challenge. So we can see here that it's running on the server, and if we actually go and netcat into it, we'll see that it says enter your username, much like what the code is saying it should. And then it says enter your 2FA code challenge response. So this is a play on Okta, which is Monash's 2FA system, and this is an example of a very bad two-factor authentication system. So I'm not going to walk anyone through this challenge, I'm just going to tell them what the underlying principles are. Basically, this challenge relies on this here, which is random.seed is username. So, for those who don't know, the way we generate randomness in computers is that it's not actually random, it's what's known as pseudo-random, and basically it's a whole bunch of maths that creates something that creates a set of numbers that is roughly random in terms of frequency distribution, but not truly random in terms of you can't trace where that number came from. What you can do is you can seed a random number generator with some string or some number and use that as its starting point. And so every single time you get a random number, it's going to use that seed, which means it's reproducible, consistent, and deterministic. Because we have control over this random seed, what we can do is we can enter a seed of our own that we know. We can then go into -3 of our own, use that as our seed there, and then what we can do is we can actually go and find out what the challenge is and which number was generated from that, and then find out what the next random number is as the response, and we can solve that. So that's pretty much all I wanted to cover. This one was always going to be a pretty quick one. Most of the forensics challenges are designed to be fairly easy and to be accessible. Let me know if you have any questions. I'm in the Discord as well as monitoring Twitch chat, and enjoy. You've got an hour 20 left.